This video is for the lab Rotational Kinematics. The lab is part 2 of the handout, so this will be helping you with part 2, and this particular spinner is for section A of part 2. This is the green platform spinner. I'm going to spin it, and you have to do two things. First, you have to time it from the instant it starts moving to the instant it stops. Second, you have to estimate how many radians it rotated. So that means you're going to have to combine two ideas. You have to count how many full revolutions it goes through, how many full rotations it goes through, and multiply by how many radians are in a full rotation, which is something you should know. And then it's going to go more than just ending here at the blue pen. And so after it's gone a little bit more, you need to estimate like how many radians more it went past the full revolution. So for instance, if it started here and went like this. Okay, that was 2 full revolutions. So you multiply by that by the number of radians in one revolution. And then you add this much more from here to here. Estimate how many radians that would be and add it. And that gives you the total number of radians. So I will do that in a second. But before that, if this were an actual in-person lab, you would measure this yourself. I will measure it for you. That's a diameter of 30 centimeters. The diameter is 30 centimeters, but in the lab handout, I ask you for the radius, not the diameter. All right, so let's actually spin this. I'll do a countdown. And as I said, you want to keep track of how many revolutions or rotations it goes through, full rotations, and then once it goes past it for the last time, estimate how many radians to tack on to that. All right, so 3, 2, 1, go. All right, so much for the green spinner. Next is part B, which is the fidget spinner. All right, so there's a fidget spinner. We're going to do exactly the same thing. This just has a much smaller radius. So when I measure the radius of this, I get 3.8 centimeters. And by the way, you want to convert things to meters. So everything will be in meters per second and so forth. So the previous one was 30 centimeters diameter, which is diameter of 0.3 meters. This is a radius. This time I'm measuring the radius as 3.8 centimeters or 0.038 meters. So 0.038 meters for this. Now we're going to do the same thing. You have to do the same thing. Time it from when it starts to when it stops, and I'll give you a countdown. And also count the number of full revolutions plus how much further it goes so that you can estimate how many radians it rotated. All right, so let's do this. 3, 2, 1, go. Okay, now we'll do it for real. All right, so 3, 2, 1. Oh, let me start over and put a pen to mark the 0 point. Okay, so 3, 2, 1, go. All right, for the last part of the lab, part C, what we would normally do is roll this baseball across the room from one side to the other, and I would ask you to figure out how many revolutions it goes through and then how many radians of rotation that is. And you get to measure any distance you want. You wouldn't actually count the number of the rotations as it goes. That's not really possible. But you have to figure it out by knowing that the distance from one side of the room to the other is 9 centimeters, or 9 meters. That's 9 meters. 9 meters. And you would measure this baseball, and you could lay the ruler across, look down, and see that its diameter is 6 centimeters. We're rounding that, just to make it fast and reckless, 6 centimeter diameter. So from those two numbers, the distance across the room is 9 meters, and the diameter, not radius, diameter of this ball is 6 centimeters. Figure out the two things I ask you for in the lab.